Okay, so differences of means and proportions. Basically, this is the one that they do in clinical trials, in clinical experiments and stuff like that, where you have a drug that you're trying to test. So let's say that you have some kind of blood pressure medicine, citrulline, whatever, and you want to find what, the effects of that blood pressure. So what you have to do is give that blood pressure to somebody, that blood pressure medicine to somebody, but now there's an effect that we have that says that, well, just because you have that medicine, you're going to get better, okay? That's what we call the placebo effect. So that placebo effect has to be controlled with. Notice the word control. So that means that we're going to have one group that's going to be experimental, that has the drug, the actual drug, and the other one is going to get the placebo. It's going to be the control group, okay? And what we're doing is this. We're just going ahead and controlling to see if there's any difference between the two, okay? So what we're trying to do is figure this out. We're trying to figure out, we have two groups, okay? We have two groups here. We have this group, and we have this group. And we have that this is the experimental group. They're giving you the drug there. In this one, they're going to give the placebo. Now, each one of them does not know which one they are. Remember, that's what we call the blind study. So this one doesn't know if they're having the drug or the placebo. This one doesn't know if they have the drug or the placebo. We know this is the drug, and this is the placebo, okay? And basically what we're going to do is we're going to find the mean, we're going to find the standard deviation, and compare it to this one, okay? Now, if the mean are equal, we can say there is no difference between the two, okay? But if the mean is not equal to, then we can say, maybe the drug didn't do well, or maybe the drug did very well, okay? Depending on, like for example, if the drug was higher than the placebo, we can say, yes, the drug did well. But if we have the placebo lower than the drug lower than the placebo, then, well, the drug didn't do well, okay? But that's the kind of stuff you're doing, okay? This is what we call clinical trials, clinical experiments, and stuff like that. Okay, so now, basically that's what we're talking about right here. So the first step is to determine what is it that we have there. What did I just talk about? Well, let's look at this one. When two samples are totally independent, totally unrelated to each other. In other words, the two groups are not related to each other at all. Okay? You got experimental people here and control people here. Totally different people. That's independent sampling. Okay? So we have independent sampling in that case. So any questions on that? Now, let's say that we had something like a before and after. Let's say that we had that drug that lowers weight, okay? You have Sanedrin or whatever it's called, and you take you have the weight before, and then you have the weight after you took the drug. Then that's going to be the same person, okay? So you're still comparing two means. But in this case, what you're doing is the two means are the same people, okay? In this case, when, for example, you have this, you have, okay, the weight before you took the drug, and then the weight after you took the drug, okay? Now notice it's the same person, so you can match them. You can match them. That's a key word, matched pairs, okay? In that case, we have dependent. This is what we call dependent sampling. So in this case, what we have here is dependent sampling. It's when two variables are paired to each other. They're linked. You can visually link them. Okay? You can visually say this one goes to this one. I don't know if in your other class they taught you about the one-to-one relationship, but that's basically a one-to-one relationship. Okay? So any questions about that? So let's look at this one right here. Let's say that we had this example right here. The following table shows the heart rates, beats per minute, of 5 people before exercise and after. Is this going to be independent or dependent sampling? What do you think? Is that independent or dependent sampling? They're dependent because they're matched. It's the same person. It's before and after. Okay? You are going to have a question like that on the test 4, and you're also going to have a question like that in the final exam. Not this one, but one something like that, where they're going to ask this independent or dependent. Okay, sampling. Let's look at this one right here. You've got the weights of 40 females, the weights of 40 males. They are independent. Very good. So that's one of the things you have to do. Now, these procedures are basically the same as the last ones, okay? The only difference now is that instead of having one group, you have 2 groups. But you're still going to have a hypothesis. You're going to have a claim. You're going to write a null and alternative hypothesis. But now this time, the way it's going to look like is this. The null means no difference. Okay, there isn't any difference between the 2 groups. And the alternative is that, well, the difference is less than, greater than, or there's just a difference between the 2 groups. Okay? Now, we have 2 different types of tests. We have like for independent sampling and for dependent sampling. Now, your final exam covers the independent sampling. So I'm going to concentrate on the independent sampling. And then I'm going to give you one about dependent sampling, okay? But most likely on your test 4, and on your final exam, you're just going to have independent sampling. Okay, so any questions on that? But these are basically the steps that you go on. Notice they're the same as the other ones. Write your null and alternative hypothesis. Is it a T or a Z? Now, how do I know if it's a T or a Z?
T is a sample, Z is a population.
The T is for sample, standard deviation, and the Z is for population, standard deviation. That's right. Then you're going to find the necessary sample statistics and the p-value. Then you're going to make a claim, make a decision, based on the null hypothesis and on your alternative hypothesis. And then you're going to do the same interpretation. I have enough evidence, I don't have enough evidence, okay? So it's all the same kind of idea. So let's give you an example. Now this one's going to be for independent sampling, okay? Now I'm going to go ahead and do it by hand because, and here's the thing on this one. I wish I could just show you the formulas for them. They are humongous. They're very big. So I'm going to show you how to do it by hand, by calculator. Because the other one would take so long. It takes like 1.5 pages to do them. By hand. Okay, so now we're just going to do this by calculator. So our first step when you're looking at this is write your information down. Okay, so I have, first of all, let's go ahead and find the null and alternative hypothesis right there. You want to buy a vacuum cleaner, and a salesperson tells you the repair costs for Model A and Model B are equal. Right there. You research the repair costs of 34 Model A vacuum cleaners and 46 Model B vacuum cleaners. The results of your research are shown in the table below. At a significance level of 1%, can you reject the salesperson's claim? Okay, let's get our information. What is your null hypothesis? Remember, the null always has to have that equal sign on it. What are they saying here? What is your salesperson saying? Exactly. That mean 1 and mean 2 are equal to each other. Okay? Model A and Model B are equal to each other. So that's what they're saying. So what's the alternative of that?
Not equal.
They're not equal. Okay, so we have this. They're not equal. They're equal and not equal. Okay? So one, the mean is equal, the other one is not equal. Now let's see, what is it the statement was? What was the claim? Yes.
Go back to that.
I will, yeah, in a minute. But let me go ahead and ask you this. What was the claim? What is the salesperson telling you? That they are
Equal.
the same, right? So the salesperson's claim is in the null. That means that the claim is in the null. That's what I'm trying to say. So the claim is here in the null hypothesis. So you would put down here, you would put claim right there. Okay, are we ready? But that's your first step. You have to write the non-alternative hypothesis, just like Chapter 8. Pretty much is a link to Chapter 8, okay? Chapter 9 and Chapter 8 go together. Now, your second step is to determine the level of significance since it's already there, okay? So it's a 1% level of significance. What does that mean? That means I'm willing to risk 1% being wrong. If I reject the null hypothesis and I say, no, they're not equal, I'm telling the salesperson, they're not equal, you're lying to me, then I have a 1% chance of being wrong in that statement. Okay? Are we ready? Okay, so now after we do that, after we determine that, our next step is to determine whether we have a Z or a T. Okay? So how do we do that? Well, we go to our calculator. Now, what kind of standard of deviation do I have? You have to go back and see what kind of standard deviation do you have here. I have a population standard of deviation. So where I'm going to go is this. I'm going to go over here to my calculator, okay? I'm going to go out to stat, go out to test, and since, how many samples do I have? 2. So I can't do the Z-test or T-test, I'm going to do the 2 sample. And it's a population standard of deviation, right? So it's going to be the 2 sample Z-test. Now we put in our information. You just look at this and just put in your information. Your first one, your standard deviation for the first one was 10. Okay. I'm sorry? There you go. So now we have the other one. The other standard deviation was 18, so we have 18 there. Now we want to find the means. Okay, so we had the mean for the first one was 50. Okay, and the mean for the second one was 60.
What was the first standard deviation?
Sorry, hold on for a moment. The first standard deviation was 10. And the second standard deviation was 18. The first mean was 50. The second mean was 60.
For your n, you put 0.
I'm sorry?
For the n, you put 0.
No. For the n, the first one was what? What is your n on the first one? 34. So you're going to put in 34. And then for the second n, it's going to be what?
46.
46. So you're just putting in those numbers in.
That's fine.
So you're going to put all those numbers in. Now again, this is going to be
X
your alternative hypothesis.
is 50. Oh, wait. It's not equal to 2.
Yeah.
Mine didn't pop up
Okay, we ready?
there. No. Mine. Is everything right?
I'm sorry?
What is your 81?
And the one would be 34 and 2.
How did you get 34 and 32?
There on the problem.
So it says 34 model A mattress.
Right.
So 46 model A.
Okay, good.
Okay, on that one, you look at the alternative. The alternative is it's not equal to. So you highlight the not equal. And then hit calculate. And you get your p-value. Okay? So we do that, we hit the not equal, and we get our p-value after that. We hit calculate, and we get our p-value. And it's basically the same thing we've done before. If your p is low, what do?
Reject the null.
Reject the null. So my p is low. If I remember, my p is below that 0.01. Okay, my p is 0.001, and that's 0.01. So 0.001 is less than 0.01. So we reject the null. We cross the null out. Okay? So what that means is that our next step is going to be saying, well, we rejected the null. So that means that if we reject the null, there is enough evidence. Remember I said, anytime you say reject the null, you have enough evidence. But we have enough evidence to do what? Reject the salesperson's claim, right? His claim was that they were both the same. They both had the same mean. They were both equal. Maybe one of them was more expensive than the other one. He was trying to sell the more expensive one. Okay? Or maybe they both were the same quality, but one had a little bit of a difference, and he just wanted to get rid of that one.
So that's your answer, the 0.0016 is less than?
Yes. So that's going to be less than that 0.01. So basically, you're going to reject the null hypothesis and say that there is enough evidence to reject the salesperson's claim. And that's your answer on that one. Okay, any questions on this? Let's look at another one. Now, look at the difference between this one and the last one. Now, this one you had a what?
Population.
A population standard deviation. The next one,
Yes.
you have a sample standard deviation. So what do you think the difference is going to be? It's the same thing. You write the null and alternative hypothesis. You figure out what your information is. Your ends are the same. So what is the big difference in between this one and the last one?
So the first one was a population?
We're gonna have
Population standard deviation. So you had to use the two-sample
And
z-test.
how do you know that?
Because they said it. They said all.
Oh, sorry, I went with.
Okay, so they said, yeah, they see the symbols?
Yeah.
They had your symbols, your population symbols. Okay, but now this one, you have a sample standard deviation. What did I say? What's the difference between the two? If you have a population standard deviation, you use the z-test, right? If you have a sample standard deviation, you have a
t-test.
t-test. So that's where we're going to go. We're going to go for the t-test. Again, we're going to go ahead and write our null and alternative hypothesis.
Is it just regular t-test? Or is it?
No, it's going to be a two-sample t-test. But wait, because there's some things you have to know about it before you go on to it. So on this one, what you have to do first, we're going to go ahead and get our information. Now, these two are independent, okay? They're independent sampling. So now what we're going to do after that is we're going to go ahead and find our information. our sample mean, our sample standard deviation, our sample size. We're going to write our null and alternative hypothesis. Okay? Now look what it says here. An advertising claims that there is a difference in the mean household incomes for credit card holders of Visa Gold and of MasterCard Gold. The results of a random survey of 100 customers from each group are shown below. Test the executive's claim at a 5% level of significance. So now what we have is this. We have our null and alternative hypothesis. So our null is always going to be equal. Okay? So your null is always going to be equal. And our alternative is going to be not equal. So they're different. The two means are different from each other. And that's what the credit card people are claiming, that they're not equal to each other. The executive is claiming that they're not equal to each other. So any questions on that?
And C means claim, right?
Right, C means claim. Okay, so now we have our information. So what kind of what sampling distribution did you have? I've already said this, but what is it, a Z or T? It's a T. So you're going to go to a two-sample t-test. Okay, so we're going to go to our calculator. Okay, and we're going to go to stat test. We're going to go to two-sample t-test. And then we're going to enter our information. The mean for the first one was 6,900, okay, with a standard deviation of 12,000 and a sample of 100. The second one was 64,300 with a standard deviation of 15,000 and a sample size of 100. Okay? Now we want to find out whether it's equal, less than, or greater than. So how do we figure that out? We look at our alternative hypothesis. So go back and look at what your alternative hypothesis was. What was your alternative hypothesis? Not equal, so we highlight not equal. Now we have this question, pooled or not pooled. What does that mean? Okay, what to do that is, now these should be population standard deviations, but because we don't have that, we're going to approximate it with our sample standard of deviation. Now these two should be squared, should be the same if it's going to be pooled. So if you square this one and square that one and you get the same number, then it's pooled. If you get different numbers, it's not pooled. Okay? That's basically what saying is that, and you might have some questions on that in my stat lab. If they say assume variances are equal, then what you're saying is, assume that population variances are equal, then you're going to say pooled. Okay? And if they say assume population variances are not equal, or they say population variances are not equal, or you got these, and there's nothing, it says nothing about it, but you have this right here. You say, well, they're not the same, so their variances are not going to be the same, so it's not pooled. We're not going to have it pooled. Basically what we have is no, not pooled. And then you're going to hit the calculate button. And you're going to look for your p-value. You're going to have the same idea. Your p-value, if your p-value is less than your alpha, you're going to reject the null hypothesis. If it's greater than your alpha, you're going to fail to reject the null hypothesis. So in this case, what do? Okay, I'm going to fail to reject. So I'm going to fail to reject. So I'm going to fail to reject. And because I failed to reject, how do I start my statement? I do not have enough evidence. Now go back to your null and alternative. What was your alternative?
They claim.
Right, but what was your alternative? What's the claim on the alternative?
Not equal.
They're not equal, so I have enough evidence to
Support the claim.
support the claim. I do not have enough evidence to support the claim. So that's how we do that one. Okay, let's try one more of these, okay? Or two more. I'm going to do another one of these. So we have this one. Let me see if I can get the volume down. This one. Okay, so this one, we have this. Okay, go ahead. You tell me. What is my null and alternative hypothesis in this case? Crash tests at 5 miles per hour were performed on 5 small pickups and 8 SUVs. For the small pickups, the mean bumper repair cost was $1,520, and the standard deviation was 403. For the SUV, the mean bumper repair cost was $937, and the standard deviation was 382. In an alpha of 10%, test the claim that the bumper repair cost is greater for small pickups than for SUVs. So how would I write the null and alternative hypothesis? We got two means,
So
one for pickups and one for SUVs,
mean 1 is equal to mean 2.
and that would be your null, right? Okay, and what would be your alternative?
Mean 1 is greater than mean 2.
Very good. So that's how you would write your null and alternative hypothesis. And where is the claim?
Alpha. Oh, the claim. The mean 1 is greater than mean 2. So
Okay.
it's your alternative.
The alternative, that's right. So the claim is in the alternative. Now what is your alpha? 0.1. So now you have your alpha 0.1. What you're going to do is you're going to go to your calculator. Okay. We're going to go clear it out. We're going to go to stat. We're going to go out to test. And we're going to go out to a 2-sample t-test. Okay. So now I'm going to enter my information. The mean for the first one was 1,520. My standard deviation was 403. My sample size was 5. My mean for the second one is 937. My standard deviation was 382. My sample size was 8. What was my alternative right here?
Greater than.
So we're going to put the greater sign. Okay? Now, is it pooled or not pooled? Well, let's see. Does it say anywhere assume variances are equal? What does it say?
Assume variances are not equal.
Okay, so if variances are not equal, they're not pooled then. Okay? And then you hit the calculate button. Now your p-value is what?
0.015.
0.015. So now your p-value is 0.015. What is your alpha?
0.1.
Your alpha was 0.1. Is 0.01 less than 0.1? In other words, this. Is 0.015 less than 0.1?
Yes.
Yes. So the answer is what? Do you reject or not reject the null hypothesis?
Reject the null.
Very good. So we're going to go ahead and reject the null hypothesis. Okay? We're going to reject the null hypothesis. Since we reject the null hypothesis, you have enough evidence. Now, where was your claim?
in the alternative.
in the alternative. So you have enough evidence to support the claim. Okay? You have enough evidence to support the claim. Okay, now let's try this one. Any questions on that one, by the way?
That was pooled, right?
That one was pooled, yes. No, wait a minute. We said assume not equal, right?
Yeah, not equal.
Yeah,
So it's not pooled.
is not pooled. Okay, so try this one. Go ahead and work on this one. Okay, we ready?
Hold on one second.
Okay.
How do you know this one? And to find that out.
They're not the same.
Okay. I mean, really, what you have to do is really get it speaking as patient. Did we the second one?
Yeah.
For sure, that was like $200. And then calculate.
Always make sure you don't highlight it.
Alternative hypothesis. Look for where it says claim. Look at this. Test the claim that the mean amount of time spent watching TV by women is smaller than the mean amount of time spent watching TV by men. Okay? So basically, you say, test the claim that the mean amount of time spent watching TV by women is smaller than the mean amount of time spent watching TV by men. That's where you have your null and alternative hypothesis. Okay? So, now that we have that, oops, sorry. So now that we have that, we're going to write down our null and alternative hypothesis. Okay? Now it's independent because you have two different samples and they're not related to each other at all. Now the null is going to be that they're equal because it's always the same. The null is always going to be they're both equal to each other. This is saying test the claim that the mean amount of time spent watching TV by women is less than the amount of watching TV by men. That's your alternative right there. Now that you have that, your next step is going to be to go to your calculator. We're going to go out to our calculator. Okay? We're going to go over here to where? Where should I go?
To sample t-test.
Okay, so I'm going to go to stat, test, to sample t-test, right? Now, let me ask you something. Are they pooled or not pooled?
Not pooled.
Okay, so basically what you're going to have is they're not pooled to each other. Okay? Now, let's go ahead and write our information, because that's the next thing we have to do, is write our information. Okay, so what I'm going to do is I'm going to go ahead and put my information in there. So I'm going to have 11.8 for the first one with a standard deviation of 3.9 and a sample size of 14. The next one is 13.5, standard deviation is 5.2, and a sample size of 17. We look at this to see what we have for the alternative. It's going to be less than, So we go over here and highlight less than. And then we're going to have pooled or not pooled. Again, did we have same standard deviations or different? They're different. So they're not pooled. So no, they're not pooled. And then you're going to hit the calculate button. And you're going to get your p-value. Your p-value is 0.1537. You compare that to your alpha, 0.05. Which one's bigger? 0.15 or 0.05? 0.15 is bigger. So that means that we do not reject the null hypothesis. We cannot reject the null hypothesis. Since the p-value is greater than the alpha, we fail to reject the null hypothesis. When you fail to reject, you say there's not enough evidence. Okay, if you think about those words, when you look at the final exam and your test on the multiple choices, that really will help you. You're going to have like 4 or 5 different answers, possible answers. You can even at least throw 2 of them out. And instead of having 25% chance, you have 50-50 chance. Because if this says, okay, I rejected the null hypothesis, no matter what, I have enough evidence. So when you look at the answers, if it says, I do not have enough evidence, you can just throw that one out. Okay? Do you understand what I mean by that? Everybody with me? So now, I do not, on this one, I fail to reject so that I don't have enough evidence. I don't have enough evidence for what? We'll go back to your null, an alternative. I do not have enough evidence to support the idea that the first mean is less than the second mean. Okay? So I do not have enough evidence to say that the mean for women is less than the mean for men. And that is my answer. Okay, are there any questions on this? Now, I'm going to do this one just because I want to make sure that you have one of these, that you've seen one of these. Now, the difference between this one and the other ones that you saw was, now you have dependent sampling. Notice the idea here is before and after, okay? So in this case, the table shows the heart rate beats of 5 people before and after exercise. We want to know if there's enough evidence to conclude that heart rate increases with exercise. So what we have is the 2 groups right here. When we do a dependent, what you're going to do is you're going to take the difference of the 2 numbers. So you're going to take before minus after. Okay? And this is off. This is before, and this is after. Okay, yeah. So now you're going to take the differences between the 2. Now what you're going to do is when you subtract them, 127 minus 65, what's 135 minus 72? Okay, what is 140 minus 85? Okay, what is 78 minus 136 minus 78? What is 150 minus 93? Okay, so we have those. Now, what is it they're asking you? Is there enough evidence to conclude that the heart rate increases with exercise? So what would I put for my null and alternative hypothesis? Well, my null is that they're equal. There's no difference between the 2, right? If that's the case, what happens when you subtract 2 numbers that are the same? No, I know, but okay, so let me show you this way. This is something from your algebra, class 2. Let me get a marker. So what happens if you have 3 equals to 3 and you subtract them? What do you get? You get 0, right? So what I'm saying is this. So if your differences are before and after, let's say that that was 3 and that was 3, what's 3 minus 3? 0. So that means that the difference of the 2 is 0, right? Okay, now in this case, we want to find out the alternative now. Okay, so we want to find the alternative. Now, what we're saying is that exercises increases heart rate, right? We're testing that, correct? So that means that if we had this, before it was 3, and we had 5 afterwards, right? So then what is 3 minus 5? I'm sorry. What is 5 minus 3? 2. It's a positive number, right? Let me ask you, what if it was the other way around? What if it was 3 here and then 1 there? That would have been 1 minus 3, which is what? Negative 2. So what we're saying is this. We want to find out if the differences are positive or negative. In this case, increasing heart rate, so we want to find out that the differences are positive, right? That's our claim. So we have those two. We have that the difference is equal to 0 or that the difference is greater than 0. In other words, there was a difference, there was an increase. Okay? After this, again, we have to determine the same thing. Is it a T or a Z? Well, first of all, what's the level of significance? Anybody see what the level of significance was on that one?
0.05.
Okay, so it was 0.05. Now, what do you use? Do you use a Z or a T on this one? Do you have a population standard deviation anywhere in there? No. So what do you have to use? T-test, a sample standard deviation. That's right. If you don't have a population standard deviation, you go for the T. Okay? So we have to have our T-test. So we have 5 pairs. So your degrees of freedom are 5 minus 1, which is 4. Okay? Now, from here, I'm just going to go ahead and do it by the calculator. So what we're going to do is this. We're going to go to our calculator. We're going to find the differences between all of those. So I have to go back and get my numbers, okay? There are my numbers. And as a matter of fact, since I already have the differences, I'm just going to go with this right here. See, I have those differences? So now I'm going to go ahead and put it in the calculator. So you put the differences in the calculator. Let me clear this off. So I'm going to have 62, 63, 55, 58, and 57. Okay? So I'm going to go stat, calc, one variable stats, and L1. And I'm going to have my numbers. So I'm going to put in my okay, so what is my mean? My difference, my sample difference is going to be 59, right? I'm going to put it over here so you guys can see. It's going to be 59. What is my standard deviation for the differences of the two? What does it say? 3.39. That is correct. So you have 3.39. And then what is my sample size? What is my pair? How many pairs do I have there? How many pairs connected do I have there? 5. So I have 5 pairs connected. Okay? And now that I have this, what I'm going to do is I'm going to go back to my t-test. So I'm going to go to stat. I'm going to go out to test. And I'm going to go out to t-test right there. Now what I'm going to do is I'm going to put in the numbers. Okay, now your mu sub O is what? It's 0. So for these, for dependent, they're always going to be 0. Your sample mean, your difference of the means was 59. Your standard deviation was 3.39. Your sample, the number of pairs was 5. And now look at this. This right here goes with this. What does that say? Greater than. So you're going to put in greater than. And you're going to hit calculate. And you're going to find that p-value. Okay, let me ask you this because a lot of students in the past have messed up on that. They say, what's 3.39? That's bigger. That's greater than point whatever. And so yeah, we're failing to reject, but that would be wrong. Why? What do you have there? Right. So you have 1, 2, 3, 4, 5, 1, 3. Okay? So that's definitely less than, what was our alpha, 0.05 or something like that? Definitely less than 0.05, right? If your P is low, what do? Reject the null. So I'm going to reject the null and say, yes, I have enough evidence to support his claim that exercise does increase heart rate. Okay? So I do have enough evidence. There is enough evidence to support the claim that the heart rate increases with exercise. Okay, so any questions on this? Okay, so basically that is chapter 9.